So next we have seen the generator main field. Okay, so we've known the function of the main field. We've known how it is connected, and we know, because our concern now is how we can test these various components with the digital multimeter. So we know now that it does not have any interaction with the frame, that is to ground whatsoever. Okay, so now let us look at the diode assembly, the diode plate, which is around the front of this exciter armature. Okay, so this is the exciter armature. This one that you are seeing here, this is the exciter armature. So this is the diode assembly. So like we explained in the section on testing of diodes, it also applies because this is a rectifier, full wave rectifier bridge for 3-phase. Okay, so in testing this diode bridge, what you do is that you place this positive terminal of the output from the diode that goes to your main field. So you put your red probe here of your digital multimeter and your black probe here, okay, under the continuity section, okay, or selection of your digital multimeter, or diode selection of a diode test selection of your digital multimeter. So if you probe with that arrangement, you have a reading, okay, because you are forward biased the diode in this case, or the diode assembly in this case. So when you reverse your hands, okay, that is, turn your positive to this terminal and then your negative to this positive terminal, you will not have any reading at all. Okay, that is the output of the diode assembly. Then on the phases of diode assembly, face to face, you will have some reading. Okay, you have reading. Face to face, you will also have reading. Okay, because if you are not forward biasing any of these two diodes, you will be forward biasing any of these two. So you have readings. Okay, so all these three, you have readings. So if you place your positive terminal here, that is your positive probe here, okay, and you place your negative probe here, you have reading. Place it here, you have reading. Place it here, you have reading. That is only 3 phases of the diode assembly. You have reading with your positive terminal here and using your negative terminal to go around. And also at the negative end, you also have reading. But when you interchange your hand, what I mean is that you take your black probe here to the positive terminal, okay, and then bring your red probe here, 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 and here. You will not have readings. So if you have readings, that means the diode is bad. Okay, now this is the diode assembly, which is somewhere here. Then this is the exciter armature, which is this winding, this one that you are seeing here. Okay, this is the yoke. So as you can see, the windings, they are also insulated from the yoke, so they don't have any business with ground. Okay, so when it's shorting to ground, that means there is problem developing already. Okay, so now if you separate, you disconnect these 3 leads that goes to the diode, and you are able to identify this common, or the start point, which is identifiable, okay, at the connection point of the diode. When you take the readings of these 3 windings, their resistances, when you take resistance reading, their resistances must be equal or about the same range. Okay, so that is what you do for it's the same thing, how you test your electric motor windings and your generator armature winding, and even the main feed winding. So you test for continuity, you test for short to ground, and then you test for, if possible, the value of the resistance, if it is still as it was when the machine is working properly. Then also you have the exciter field winding. Okay, the exciter field winding is always on the stator. Okay, that is around this the front of this housing that is coupled to this main stator housing the exciter armature and the generator main armature. Okay, so now the exciter field is here, and this is what is represented here now. Okay, these are the two terminals that are fed from the AV arrow. Okay, so they still don't have any connection, any business with ground. Are we getting it? So continuity, and you test for continuity, test for short to ground, and open circuit. Okay, those are the kind of tests that you can carry out on the exciter field. Okay, let me show you the exciter field as it is. This is it. Okay, this is the exciter field on the frame of the generator. It is stationary. Why this is the exciter armature? Okay, as you can see. So this exciter armature rotates with the rotor, and here we can see the diode assembly as explained earlier. So the wires, the output from the AVR, which is this two from the positive red and negative black from the AVR, is fed to the exciter feed. So that helps to magnetize the exciter field. Okay, so that magnetism will now induce voltage into the rotating exciter armature for us to have the the voltage, okay, that will be sent to the rectifier bridge or to the diode plate that will now be rectified and sent to the main feed to magnetize the main feed. So that is how we have the exciter armature, exciter feed, I mean to say. So now this is the terminal block of the generator when you open it. Okay, so you can see that we have some lead outs. Okay, so we have 6 lead outs here, we have 3 here, and then we have some here, and then we have some here too. Okay, so these are the phases of the generator. Let's assume that this is line 1, line 2, line 3. That is phase 1, 2, and 3. So this is the start point, okay, which is the same with this star point. Okay, this one is taken to the neutral as we explained earlier. This is line 1, line 2, line 3. So these are what we have here now. Are we getting it? So the start point, the neutral, line 1, line 2, line 3. So when the generator is working, you take your digital multimeter to the AC volt selection. Okay, when you probe between the phases, say line 1, line 2, you are supposed to have 415 volts. Line 2, line 3, you are supposed to have also 415 volts. Then line 3, line 1, you are also supposed to have a 415 volts. Okay, so now this is the start point, as we said. This is the midpoint of the windings. Okay, which means that whatever you have here, you have half of it on this part. So if we are having 415 face to face here, we are supposed to have 220, okay, or 200 face to face here. Okay, then neutral, from neutral, if you place your black probe on the neutral, okay, while you are on the AC voltage selection on your digital multimeter. So black probe neutral, your red probe to line 3, that will give you 220 volts. To line 2 will give you 220 volts. To line 1 will give you 220 volts. So to this midpoint, it will give you 110 volts. Okay, so this is the positive terminal from the AVR. This is the AVR. Okay, this is the positive terminal. Okay, and this is the negative terminal. So which means that we have DC voltage coming out from the AVR, and this one, black and red, they are sent straight to the exciter feed, the one on that stationary part of the stator cover, okay, on the generator stator. So now this one feeds straight to the exciter feed. So when you disconnect this, you can get your continuity outside, okay? You get your normal resistance if you have been taking resistance reading on the exciter feed before. Then you don't expect it to read to ground, okay? But that will be a fault. Then these are the phases, okay? Life and there is from the, these are, we take it from the midpoint of the generator. So, which means that this is giving us about 220 volts. So about 220 volts is sent to your AV arrow, okay? So this 220 volts is what is now converted to your 12 volts DC that is sent to the exciter main field, okay? So this is the arrangement that we have. So this is the exciter, this is the main main generator armature, okay? Here you get the output from. So this is your line 1, line 2, line 3, and this is it, line 1, line 2, line 3. So this is the start point where you have those 3 wires connected to be the start point from the other ends of the 3 windings, and this is it, okay, which is now forming the neutral of the generator. So this is it, okay? So when you take between when the generator is not working, you take between here and here, okay, you will get the resistance of this winding. Between the neutral and line 2 will give you the resistance of this winding. Between the neutral and line 1 will give you the resistance of this winding. And you expect all of them to be equal since they are the same, okay? So then the diode plate is also on the rotor, except you lose the front end, you cannot access this, okay? Then the exciter armature is also on the rotor. So all of these, they are on the rotor, okay? You can't access it. Then the exciter feed winding, okay? This is the exciter armature. The exciter feed winding, which is on the surface, these are the 2 wires coming from the exciter feed. These 2 wires that goes to the plus and minus of your AV arrow. Are we getting it? So these are the 2 wires that goes to the AV arrow, and the AV arrow supplies the exciter feed with DC voltage. Okay, sorry, this is the exciter feed with DC voltage that helps to create that magnetism that will induce voltage into the exciter armature, and this the voltage that is induced into the exciter armature is rectified and sent to the main feed, which will in turn magnetize the main feed, and that magnetism, okay, rotating magnetism, since the rotor will be rotating when the generator is working, that will now induce voltage into the main armature, okay, where you get your output power from. So when you are testing too, this is also like a diode. So when you have your input, okay, to the AVR, you are supposed to have DC voltage. That you take your digital multimeter to the DC voltage selection, and then when you probe, take your red probe to F plus and your black probe to F minus, you are going to have 12 volts if that AVR is a 12 volts AVR that is giving out 12 volts, okay? So you get that 12 volts. If you are not getting that 12 volts, that means there is something, especially when you are having an output from the generator, okay? And there's what we call the initial magnetism. If it is there, say about 5 volts, okay, if you have it there and this thing is not magnetizing, or you try to excite with a battery, that is, you remove this plus and minus wire and take it to your battery, and it actually produces your normal AC voltage, that is 12 volt battery. This this red lead that goes to the F plus, you take it to the positive terminal of your 12 volts car battery, Then the negative lead, the black lead, okay, from F minus, you take it to the negative terminal of your car battery, which is the battery you use to start the unit. Yeah, if you have your normal voltage, and when you, after you connected the AVRO, you are not having your normal voltage, it means that the AVRO have some problem, okay? So once the inputs are there, you are expected to have the full, that is the 12 volts, okay? So you can excite, disconnect F minus and F plus, excite with your 12 volts battery. You are expected to have 12 volts here. Or you can take the AVR to do bench test, supply it with 110 volts, and you expect to have 12 volts DC from these two terminals, okay? Then there are times, there are some problems you also have with the diode assembly that you don't really need to ask much question as to the cause of the problem. Because when if any of this one is shorted or open, okay, you discover that it is possible that the generator will produce its normal voltage. Okay, you have your normal output here, 415 normally. But as you load it, it will drop on load, okay? It will drop to 0 volts on load. So the usual culprit for such a situation is this diode assembly. So you can just move straight to the diode assembly and check for their integrity. So what you are seeing on your screen now, okay, is the windings, okay, the windings of the main armature for the generator. So this terminal 1, 2, 3, which are now connected to 1, 2, 3. They are this terminal 1, 2, 3, and which are these terminals 2, 1, 2, 3. Okay, here you get your line 1, line 2, line 3. Okay, line 1, line 2, line 3. So the midpoint from each of the winding is around this area. Okay, so when you break this midpoint, you have 2 lead outs, okay, from each of them, which will eventually turn 6. So these are the 2 liters from those midpoints. 2 from phase 3, 2 from phase 2, 2 from phase 1, okay? So since it is the midpoint, you have half of what you are having from this terminal, okay? So this is the diode plate that we were discussing earlier, okay? And this is the representation of the diode assembly that is contained in this plate. So when you look at the diode assembly, you see that we have 6 diodes. One set is forward bias, the other set is reverse bias, okay? So which means that one end, let's assume this is the negative end of the diode, and this is the diode plate, and this is the positive end, which means that your exciter, the 2 wires that comes from this main feed, okay, will run through to these 2 terminals, okay? Then these diodes, you can test them normally the way you test your normal diode. So like we said, these 3, okay, let's assume that they are these 3. It means that when you place your red probe here, your black probe here, it will read, but when you reverse, it will not read. Are you getting it? So you do the same thing for each of them to know the one that is 40. So also too with the other one on the other side of the plate, okay? When you put your black probe here and your red probe here, it will read, but when you reverse your hands, it will not read, okay? That is how it should be. So if you are having something contrary, or they are shorted to, if you are having something contrary, of course, that will mean that something is wrong with the diode plate. So you identify the diode that is 40 and replace it. If you cannot replace that particular diode, that means you replace the entire unit, that is the entire diode plate. So this is the thermistor. And the function of the thermistor is to protect the entire circuitry. In case you have lightning strike that causes voltage transient, very high voltage transient that may be induced and sent into the main feed. I will know the implication of that. That can cause excessive magnetism and overinduction of voltage into the main exciter, the main armature of the generator, and then produce excessive voltage that will blow up equipment, okay, tied to that generator in your facility. So what this does is that once that excessive voltage comes, it will blow up and breach the phase and the neutral, and then that will mean that the positive and negative, okay, that will mean that whatever voltage that will be coming, supposed to come to the main field, will be shorted. Okay, so the generator will not produce at that end. So it would have succeeded in clipping the excess voltage that was induced through or by the lightning, okay, and thus protecting the generator and eventually protecting all the downstream equipment in your facility to the generator, okay. So that is how, and this normally, if it is working normally, when you take your meter to your home range, okay, your continuity range, you will not get any continuity. But once it's bad, you will hear ping, that it will be reading continuous, showing that it is continuous. So that tells you that that one is faulty,